So let's go to domain 2 of CompTIA Security Plus. Domain 2 is architecture and design. So the weightage for architecture and design module is 21%. So which means if the total marks are out of 100, then 21 marks of questions will be coming from domain 2. So in domain 2, in the first section, we will discuss about the security concepts that are related to an enterprise environment. So we start with configuration management. See, we have information systems and we have applications. Information systems and applications. For each information system and application, we have to define a security baseline. Security baseline will say what are the minimum security configuration each of our systems or applications should have. So we have to define the security baselines, we have to document them, and whenever changes are happening to security baselines, it has to go through a change management procedure, and different versions of the security baselines has to be identified by different version numbers. So all these things comes as a part of the configuration management. So configuration management is important. Essentially, when we are talking about architecture and design, this particular module, here we are discussing about the essential aspects that we have to know in order to design a secure environment. So first we will go through the different concepts that are relevant to a networking environment or IT infrastructure environment. So we start with configuration management, then we move to data protection. We have data. So the data that we are using in our organization, it has to be processed based on the relevant laws and regulations. Then it has to be protected. So what are the different data protection mechanisms? We will discuss them one by one. Then we will also discuss what is called as a hardware security module. So hardware security module is nothing but it is a hardware which has a processor, it has encryption keys, and it is used to protect information. So in data protection schemes, we discuss encryption. Encryption is one of the methods that we use to protect the confidentiality of data. So implementing encryption in hardware, that is what is called as HSM. Then we will also discuss what is meant by a cloud access security broker. To protect information and information assets on the cloud, we use tools like CASBs. For secure network communication, we use HTTPS. HTTPS is a secure web communication protocol that is built on SSL or TLS. SSL or TLS is the security protocol that provides security to web communications. SSL is no longer considered to be secure, so the use of SSL should be discontinued. Instead of SSL, we should be using TLS. Hashing is a mechanism that is used to implement data integrity. Any changes to the data that has happened, in order to identify that, we use hashing mechanisms. Then site resiliency. See, we as an organization, we may be faced with disruptions and disasters. If we are faced with a disaster, it may not be able for us to continue operations from our primary facility. So we may have to move to an alternate location, and we may have to start operations from there because our primary facility is not operational. For example, let us say our primary facility is faced with a flood. We don't know when the flood is going to subside. So we have to move from an alternate location. So what are the different types of alternate locations? Hot sites, cold site, warm sites. All these things we will discuss. Then to redirect the attention or the focus of attackers, we use deception and disruption methods. What are the different deception and disruption methods? That also we will discuss. Now in this section, we will go through the essential aspects of virtualization technologies and cloud computing concepts. So the fundamental concept, the basic concept of cloud services is the concept of virtualization. So what is virtualization? What all types of virtualizations are there? We will discuss that. Then we will move to cloud. In cloud, we have different types of cloud platforms: public, community, private, hybrid, and we have a lot of services: infrastructure as service, platform as service, software as service, anything as service. So we will discuss all these concepts. We will also discuss about the main cloud service providers. Then we will discuss managed security services. Let us say we need to implement security, cybersecurity in our organization. There are two options. We hire a team, we procure the appropriate tools, and we implement security. Or we can contract the services with a third party. So managed security service providers are third party service providers who provide security services. Then we have the concept of fog computing, edge computing. We will discuss it in detail when we come to those sections. The concept of thin clients, the concept of containers, again, that is based on virtualizations. Based on the concept of containers, we have microservices. We have services and microservices. What is meant by microservices? We will look into the essential details. Then we will look at the concept of SDN, software defined networking. So this is also a new approach to networking, a new concept. This concept was originally introduced in industrial control systems. Now they have moved to the IT infrastructure environment. So what is the concept of SDN? What is the concept of SDV? All these things we will discuss one by one. Next, we go into the application development area. How do we secure applications, or what are the security aspects that we have to consider when application development is happening? So this is something that software developers do. So when software developers are working on applications, what are the things? What are the security concepts they have to keep in mind? So we look at the different stages, or we look at the different environments in an application development area, like the development area, testing area, staging area, production area. Then we will go into the techniques that are used for secure code development. There are certain best practices that can be followed for secure application development. One such best practice is it has been developed by the Open Web Application Security Project. So OWASP basically maintains a database of all the security application security related vulnerabilities and threats, and they also have best practices developed for secure application development. So we will discuss that. Then we will come to automation. See, in the earlier days of software development, changes to the software was happening very rarely, maybe every 6 months, every 3 months, etc. But in today's environment, the changes that are happening to the applications are very rapid. Every day you can expect multiple changes happening to the applications. So you have to make changes to the applications. You have to ensure applications are secure. You have to ensure that when applications are being launched, no security, no issues happen. So to make all these things happen faster and faster, automation is required. So what are the aspects related to application deployment automations? What are the security aspects related to it? We will discuss them one by one. Next, we will look at the authentication and authorization concepts. So what is authentication? Authentication is, let us take an example. I am submitting a username and password. I am logging in using a username and password. Username helps to identify you, that is identification, and password is used for authentication. So password is used to authenticate that you are the correct person. So there are different methods for authentication. Even though passwords are the most commonly used methods for authentication, there are different methods that are available. What are the different methods of authentication? We will discuss one by one. All those methods are listed here. Biometric is also another method of authentication. Again, there are different types of biometric authentication: fingerprint, retina, iris, facial. So one by one, we will look into the details of how authentication happens using these two methods that is captured here. Then we have the concept of multi-factor authentication. See, normally we log in using a username and password. Sometimes, in addition to the password, we will also give a OTP, or you will use a fingerprint. So authentication is not happening based on one thing. Authentication is happening based on multiple things like password, PIN, OTP, fingerprint, etc. This is called as multi-factor authentication. So when you are doing multi-factor authentication, you do multi-factor authentication when the information that you are trying to protect is very sensitive. So what are the concepts related to multi-factor authentication? Then we will also discuss the concept of AAA. Authentication, authorization, accounting. So what is authentication? We have seen. Now what is meant by authorization? I log into a system using a username and password. So username is used for identification, password is used for authentication. After that, I'm trying to access, or I'm trying to open a file. When I'm trying to open a file, authorization will happen. So authorization will check what is the permission I have on that particular file. Is it just to open the file, to modify the file, to delete the file? So this checking is called as authorization. Accounting means I log into a system, and on that particular system I am doing so many things. Whatever I am doing, it is being tracked. The information related to my activities are captured into a file called as a log file. Now this is called as accounting. So systems that can do authentication, authorization, accounting, these are called AAA systems. Now in this section, we will talk about cybersecurity resilience. Now what is meant by resilience? Let us take an example. I have a cybersecurity attack. As a result of the attack, some of my data has been lost. Even though the data has been lost, I am still able to recover my data. That is an example of cyber resilience. So where do I recover the data from? From backups. So backup is an example of cyber resilience. Or sometimes my server has been hit with an attack and my server goes down. So when my server goes down, now my customers cannot have access to the services. So even if my server goes down, I still have another server that can provide services to my clients. This is another example of resilience. So there are different mechanisms for resilience. We will discuss each mechanisms for resilience. One is disk redundancy. So it is related to resilience of hard disks. Then network resilience. Examples of network resilience, we have failover clustering, we have something called as network load balancing. Then resilience for power systems. Even if one power system fails, we still have a backup. Data backups are another example of resilience. In addition to all these things, we also have other options like option to take backup of our information onto the cloud. Then we also have the concept of high availability. So high availability means I have two systems. Even when one system is down, without an outage, automatically the switchover happens to the next system that I have in place. So what are the different technologies that are involved in providing cybersecurity resilience? We will discuss all of those technologies. We will discuss all of those concepts one by one. Then we will look at some specialized systems. See, in a network, in a traditional network, we used to have regular network devices like laptops, desktops, mobile phones, servers, network devices, applications, etc. etc. But nowadays, the kind of devices that are connected to a network or an internet is very, very different. Some examples of and these kind of devices are classified as specialized systems. These specialized systems have embedded software. Some examples of embedded specialized devices are given here. Industrial control systems. These are specialized computers that are used in industries to control the parameters of the industries. IoT devices. IoT devices are our home-based, our office-based devices that can be remotely controlled. So in all of these specialized systems, there is a software installed, and this software has networking capability, which means it can communicate over the network. So an example of a IoT devices, let us say I have an AC installed in my home. It can be remotely controlled through the internet. That is an example of IoT. Or your refrigerator, or your garage door, or a CCTV camera. So any appliance having a networking capability which can be remotely controlled is called as IoT. Other examples of specialized systems are even vehicles are connected to the network, medical systems are connected to the network, voice over IP systems for voice communications, air conditioning systems, HVAC systems, printers. So CCTV cameras, these are all examples of specialized systems that are connected to the network. Now the challenge of specialized system is cybersecurity is matured for IT devices. These are not regular IT devices. These security is not matured for these specialized systems. So it is easy to attack specialized systems. Once somebody attacks a specialized system, from the specialized system, it is easy to attack other machines in our network. So understanding specialized system, understanding their security is very important in today's cybersecurity environment, because these systems are especially prone to or especially vulnerable to cybersecurity attacks. Now we are coming to physical security controls. In physical security controls, what are the different topics that we will discuss? We will talk about things like gates, windows, security guards, visitor management systems, issuing badges to employees, issuing access cards to employees so that they can swipe and get into the facilities, using CCTV cameras, using security guards in our organization, using locks, fire suppression systems, using appropriate lighting, fencing. So there are so many things. These are all physical security aspects. So what we will discuss in this section is what are the physical security controls and how these physical security controls are related to cyber security. What is the relevance of these physical security controls in the cyber security environment? We will discuss them one by one. Then we come to the concept of cryptography. So we said cryptography is something that we use to protect our network communications. So in network communications, we are sending back and forth data. To protect the communications, network communications, we use cryptography. So in cryptography, the main things that we will discuss in cryptography is one is encryption. What is meant by encryption? What are the different types of encryption mechanisms? What are the different types of encryption methods, encryption algorithms? How encryption should be used? All these things one by one we will discuss. We will also talk about the latest concept, which is quantum cryptography also in this. So we will talk about encryption. Once we talk about encryption, then we will move to something called as hash algorithms. So hash algorithms are used in a cryptographic environment to implement data integrity. somebody is making changes to our data without our knowledge, we want to detect that, or we want to know whether that has happened. For that, we make use of data integrity. Then we make use of something called as authentication and non-repudiation. So authentication and non-repudiation are implemented using what is called as asymmetric cryptography. So we will go through the concepts of asymmetric cryptography. What are the basic concepts? How using asymmetric cryptography we can implement digital signatures, non-repudiation, authentication. All these things from a conceptual perspective we will discuss. So if we look at the topics that we are covering in this domain 2. In domain 1, we understood all the threats, attacks, and the methods to assess the security posture of our organization. In domain 2, we are actually trying to design a secure cybersecurity environment. So as a part of designing a secure environment, what all concepts we need to understand? That is what we are covering in this module. We are covering the basic security concepts associated with any enterprise environment. Then we will understand the concepts of virtualization and cloud computing. Then we will understand the concepts related to secure application development. We will understand the concepts related to authentication, authorization, and accounting. Then we will understand the concept of cybersecurity resilience. We will see what are the challenges posed by embedded systems or specialized systems in a modern day network. We will understand what are the different type of physical security controls that are relevant to cybersecurity, and in the end we will understand cryptography. So by the end of this topic, we will cover the basic security concepts that are required to design a secure environment.